A pleasant day to everyone. This is Maria Concepcion B. Mendoza, your lecturer for today's topic, which is all about Introduction to Algorithmic Complexity. But before that, let's start first with the definition of algorithm. So what is an algorithm? It is an organized sequence or list of clear steps or operations needed to solve a given programming problem. It has three components. We have any well-defined computational procedure that takes some value as our input, the steps or instructions, and produces some value as our output. Say for example, we will compute for the sum of two numbers. We have to take into consideration the inputs, the steps, and the output. If we have that problem, our input are the two numbers, the steps or instructions. Since we are computing for the sum, we have addition, and the output is of course the sum. It is also a sequence of computational steps that transform the input to output. So it is a problem or a means to solve a problem that can be solved in many different ways. Okay? So many algorithms can be used to solve the same problem. So hindi porket iisa yung problem, iisa lang yung possible algorithm niya. So marami yon. So iba yung algorithm ng isa, iba rin yung algorithm ng isa. Pero iisa lang yung problem and output. But we have to choose between these different algorithms based on their efficiency. So, titignan natin ngayon, for example, this is the algorithm 1 and algorithm 2 solving the same problem. Tignan natin yung efficiency niya. Ano ba yung tutukoy na efficiency? It is a good metric of efficiency is the computational complexity of an algorithm. So, titignan natin which is best based on its efficiency. I have here the characteristics of an algorithm, wherein it must take an input, it must give some output. We have the definiteness, wherein each instruction should be clear and unambiguous, meaning the procedures should be understandable. Finiteness, wherein an algorithm terminates after a finite number of steps. And lastly, its effectiveness, where every instruction should be basic, meaning you should have to provide simple instructions or steps only. We have the term runtime complexity. We will define a notion of runtime complexity which will allow us to compare the speed and space requirements of different algorithms. For example, we will want to answer these questions like, which of two sorting algorithms runs the fastest on large arrays? Or, which uses more space? Or, how can we tell that a particular sorting algorithm will be infeasible if it takes far too much time without actually running it when attempting to sort arrays of size 10,000. In analyzing different algorithms for speed and space, we should not depend on the computer on which it is running, thus the operating system being used and so on. Our analysis of the algorithms will be independent of such considerations. We have the design issues of algorithm. Okay? So, yung design issues natin in algorithms, we have the correctness and efficiency. So, kailangan tignan natin pag nag-create tayo ng algorithm, its correctness. Does the algorithm solve the computational problem? Okay? So, nasagot pa yung problem dun sa ginawa mong algorithm? Or, nasagot nga pero iba pala yung output niya? Okay? So, take note also of its correctness or sabihin natin accuracy. Another is the efficiency. So, how fast can the algorithm run? Tingnan rin natin kung gaano kabilis yung algorithm natin. So, baka mamaya masyadong maraming steps na hindi naman kailangan, okay? Or pwedeng kayang-kaya lang pala ng mabilisan. Yun nga lang, mabilis nga siya, pero the output is iba naman. So, magko-contradict na naman doon sa correctness. So, kailangan correct and at the same time, efficient. Okay, next, analyzing algorithms. Bakit pa kailangan natin mag-analyze ng algorithms? Diba pwedeng i-program na lang kaagad-agad? Okay. Because we have to achieve the intended use of algorithm. Okay. We have to predict the resources as to memory. Okay, so memory it consume. So titignan ninyo kung may memory ba na nakukonsume dun sa algorithm natin. Baka mamaya may mga dineclare tayo dong variables na hindi na pala natin kailangan. So it will consume a lot of memory. Next, we also have communication bandwidth. So you have to know also how your algorithm will communicate to other resources, to other programs and functions, and also to the computer hardware. And the last one is the computational time. Titingnan natin kung kaano ba kabilis yung ating algorithm. So, dyan na magpo-fall yung time complexity natin. Kaano ba kabilis yung ating algorithm? It is how long na ma-execute or how long na matatapos yung program natin. So, that is our goal. Why is there a need for algorithm analysis? First is to study its behavior. So, alamin natin yung behavior niya. What happens if the input size is increased? For example, pag kokonti yung input mo, mas mabilis. Paano kapag dumami na yung input mo? Is there a tendency na baka mabilis pa rin ba or baka bumagal na? Like for example, kung ang input mo ay 10, mabilis pa. Paano kung umabot siya ng hundreds, thousands, or millions? So, tendency, baka babagal na yung process ng algorithm natin. Okay, another is to predict its performance, such as speed and space consumed. So next, we have measuring the time. So how should we measure the time taken by an algorithm? So we can do it experimentally by measuring the number of seconds it takes for a program to run. So this can be useful but depends on many factors. We have the machine on which it is running, considering it, the language in which it is written, referring to the programming languages used, the skill of the programmer, and the instance on which the program is being run, both in terms of size and which particular instance it is. So it is not an independent measure of the algorithm, but rather a measure of the implementation, the machine, and the instance. We have also here the complexity. So the complexity of an algorithm is a device-independent measure of how much time it consumes. So rather than expressing the time consumed in seconds, we attempt to count how many elementary operations the algorithm performs when presented with instances of different sizes. The result is expressed as a function giving the number of operations in terms of the size of the instance. This measure is not as precise as a benchmark, but much more useful for answering the kind of questions that commonly arise, such as, I want to solve a problem twice as big. How long will that take me? We can afford to buy a machine twice as fast. What size of problem can we solve in the same time? So the answers to these questions depend on the complexity of the algorithm. So now let's have the algorithm analysis methodologies. We have the Apriori Analysis and the Aposteriori Analysis. Let's start with the Apriori Analysis. A priori analysis is the amount of time a single execution will take or the number of times a statement is executed. Space consumed may also be estimated. This method determines the efficiency of an algorithm based on or derived from mathematical or logical facts. So in here, we will analyze the algorithm line by line. So it's more on theoretical. So we have here an example of an Apriori analysis of algorithm. So later on, I will discuss paano nakuha itong computation na ito. So we are referring to the frequency count. But if you will take a look on this, it has the interpretation or na-analyze siya per line. So our assumptions here, instructions are executed sequentially and each instruction takes one time unit. Next, we also have the Aposteriori Analysis. So this method determines the efficiency of an algorithm based on actual experiments. It is also the study of exact time and space required for execution. So in a posteriori naman, ito na yung runtime. Pag na-run mo na yung program mo, doon mo na makikita yung efficiency ng algorithm na nagawa mo. So, for example, you are using Java or you are using C as your programming language. Nung nag-implement na yung algorithm mo, at doon mo na nakita yung efficiency niya. So, that is a posteriori. So, I hope nasundan nyo yung difference ng dalawa. Yung a priori, yung algorithm nyo is line by line pa. Iko-compute nyo yung time complexity niya. Kung gaano siya ka-efficient. Sa a posteriori, during runtime na, dun sa program, dun mo na makikita yung efficiency niya. So we have here two separate sets of two algorithms and let's try to see if how it works or ano ang mas efficient. So let's start with this first one. So we have two algorithms here, Algo 1 and Algo 2. We have here two columns. The 10 here and the 100 here, we are referring to the number of inputs. Okay? So, if our input is 10, ang efficiency ni Algo 1 is 1 second. Si Algo 2 naman ay 3 seconds. So, ibig sabihin, pag 10 yung input, mas mabilis si Algo 1 compare kay Algo 2. Pero kung ang input na natin ay umabot na ng 100, si Algo 1 is nagawa niya or na-execute niya in 10 seconds while si Algo 2 naman is 15 seconds. So therefore, Algo 1 seems more efficient than Algo 2 because, yun nga, mas mabilis given a certain number of inputs. Okay. How about if we have the following already, nadagdagan? At 1,000 in number of inputs, si Algo 1 na-perform niya within 100 seconds. While si Algo 2 na-perform niya in 30 seconds. So, is Algo 1 pa rin ba ay faster than Algo 2? So, in this example, habang dumadami yung input ni Algo 1, bumabagal siya. So, therefore, in this table, Algo 2 now is faster or efficient than Algo 1. Kasi kung pansin mo, 1,000 na yung input niya. In 30 seconds na kaya ni Algo 2. But ni Algo 1, umabot ng 100 seconds. How much more kung aabot yan ng 1,000, 100,000, or million? Baka mas lalo nang babagal si Algo 1. Okay, so that is in a posteriori. Next, we have the frequency count, which refers to the number of statements or steps needed by the algorithm to finish. So this is an example of computing using a priori analysis. We have simple statements. So in computing for the simple statements, we will count it as 1. So for instance, we have A is equal to 10, we have 1, B is equal to A times 2, that is counted as 1. Another, we have conditional statements. For conditional statements, and we are using the if-else, we have here the presence of the condition, statement 1, else statement 2. So in this, in computing for the frequency count, we will get for the condition which is counted as 1, and then we will add whichever is the maximum among the two statements. Okay, so let's have an example of conditional statements. So in here, we have the condition: if x is greater than 1, y is equal to 10, else y is equal to 20, or z is equal to 30. So let's have first the simple statements. So y is equal to 10, that is counted as 1, y is equal to 21, z is equal to 31, so that is counted as 2. Now, let's get for the total. So in doing that, we'll have to know whichever is the maximum among the statements. So ang maximum dito ay 2. And then, we'll get for the condition which is 1. So 1 plus 2, we have 3. Okay, next, let's have iterative statements. For iterative statements, we have the different looping statements such as for, while, and do while. So in the following formula, we use the for loop. We have for the counter I lower bound to upper bound. So LB is lower bound, UB is upper bound, and then the statement. So if we have this one, the computation, upper bound minus lower bound plus 2. So yung upper bound natin is ito, minus the lower bound here plus 2. And if we have the statement, we have upper bound minus lower bound. So kukunin pa rin natin ito dito. Plus 1. So if you will notice, magle-less 1 ka lang dun sa naunang computation. We have here an example. For I is equal to I to n, x is equal to x plus 1. So let's apply upper bound and lower bound. Upper bound minus lower bound plus 2. So minus 1 plus 2, that is plus 1. So the answer, n plus 1. And then next, this is a statement. We'll apply this one, upper bound minus lower bound plus 1. So upper bound, so dito ulit tayo titingin, minus lower bound plus 1. So cancelled ito because that is 0, so the answer is n. So as mentioned earlier, kahit na hindi na i-follow yung formula, basta i-less mo na lang dun sa naunang computation. So n plus 1 dito, mag-minus 1 ka dyan, kaya ang sagot na dito is n. So the total, we have 2n plus 1. Another example, we have the combination of conditional and iterative statements. We have this one. So, if you will notice, there are two conditions. X is less than 1 and x is less than 2. We have several statements. We have this one, and this one. So, now let's have first the counting of those statements. So, for this one, y is equal to 10, that is a simple statement counted as 1. This is counted as 1 and counted as 1, so we have 2. And for this one, we'll apply the upper bound and lower bound, since this is a for loop or iterative statements. So our upper bound is x minus lower bound 1 plus 2. So the answer, x plus 1. And this is a statement, so we'll have upper bound minus lower bound plus 1. So our answer here is x. So we have computed already the different statements in every condition. So dito, ang maximum sa kanila ay ito, under this else. So ibig sabihin, ito ang ika-count natin. We'll no longer count this one and this one. So in getting for the total frequency count, ang i-add na lang natin ay yung mga conditions. So for the condition x less than 1 counted as 1, x less than 2 counted as 1, and then the maximum we have added 2x plus 1. Okay, and getting for the total, we have 2x plus adding the constants 1, 1, and 1. So we have 2x plus 3. Next, another example. So let's start with this one. That is a simple statement. So that is counted as 1. Next, this is an iterative statement. We have used the while loop. So we'll apply upper bound minus lower bound plus 2. So our upper bound is n minus lower bound x plus 2. In order for us to get for the result, we'll substitute x. So ang value ng x natin is 1. So we have here n minus 1 plus 2. So our final answer, n plus 1. And then lastly, this is a statement. We'll use upper bound minus lower bound plus 1. We'll substitute again the value of x, n minus 1 plus 1. So this is 0 or cancelled. So our answer is n. So the total, we have 2n plus 2. 1 plus 1. That ends my lecture on Introduction to Algorithmic Complexity. More examples will be provided on frequency count next video lecture. Thank you.